Alright, so this video is going to take us through lesson 3.2, where we're not talking about measures of central tendency, but measures of variation. So let's go ahead and get started here. We're going to start with this slide that has a picture of two basketball teams on it, and you can see the size of these basketball players. Here we have the white team. They go from 6 foot tall to 6'6". But the green team goes from their shortest player is 5'7" and goes all the way up to 7 foot tall. What's interesting about this group is that they have the same average. So if we were to put each of these into our calculator, let me show you. I did this before I started the video, and I put their heights in here. And if I went ahead and found the average of list 1, I would go to calculate, and you can see that the average height of somebody on the white team, which I have in list 1, is 75 inches tall. And if I do the same thing with the green team, let me clear this first. If I do the same thing with the green team, I'm going to go to calculate one variable stats, except this time I'm going to go list 2 here, and it also gives me an average height of 75 inches. So their averages are the same, their centerness is the same, but what is different is their variation. These dudes here, they're all the same height, okay, very close to it, from 6 foot to 6'6". They don't vary very much from each other. They're all kind of the same. Where you can see in the green team, 5'7" and 7 foot tall, there's a wide range of heights with those 5 individuals. And so we have the measures that we're going to talk about today are measures of variation and how those are different. So let's take a look first of all at their highest and lowest person and find their range. And so the range is the distance from the highest person to the lowest person, or the highest number to the lowest number. So you can see with this white team it's 78 minus 72, so their range is going to be 6. But on the green team, from 84 to 67, if we subtract those, that's a range of, I think, 17. And so a range is a good way to measure how varied data is. The range of a data is given by this formula, the maximum number minus the minimum number. And so we don't use this, we use this quite a bit actually, but it's probably not the best way to measure somebody's variation, because it only takes into consideration the highest and the lowest person. You can see it's just 2 people that determine the range of a set of data. And everybody else could be the same. And so, excuse me, another way to find the variation is to find the standard deviation. The standard deviation is different than the range because it takes into consideration every single person, and it averages their distance from the average. And so you can see the definition down here. A sample standard deviation is an average distance from the mean for each data point in the sample. And so it has to be found in a different way, which we're going to talk about here in a little bit. But it does give you a very good number that shows you how varied the data is. The more the variation, the larger the standard deviation is going to be, because it's the average distance away from the mean. So let's take a look at this formula that we have for finding the sample standard deviation and our heights of those basketball players. And so here's how this formula would work. It's hopefully we understand this, but let's just go through this, and I'm going to do the white team here, the heights of the white team here, and I'm going to have you work on the heights of the green team, which are over here. And instead of using like 6'1", 6'4", I'm going to use the 72, 73, 76, 76, and 78. One thing that we do know is that their average is 75. And so what this means here in the parentheses is that we're going to take each number, each data point, like the 72, and we're going to subtract the average. and then we're going to square that. And so, for example, if I take 72 minus 75, 72 minus 75 is negative 3. I'm going to just add these together. Let me start with negative 3 again. Let me clear this and start over. So we have negative 3 plus, and then I'm going to take the next data point, 73 minus 75, well that's negative 2. And then 76 minus 75 is 1. And another 76 minus 75 is 1. And then 78 minus 75, well that's 3. I can't just add, this is the distance away from the mean of each of those numbers. And I can't just add them together, because if I do, I will always get 0. Because the average distance from the mean is always going to be the same if I use positive and negative numbers. And so the reason why this has to be calculated in a different way is because I don't want to just get a 0 each time. What I'm going to have to do is square those distances. So here what I'm going to do is I'm going to take the negative 3 squared plus the negative 2 squared plus the 1 squared, which is 1, plus another 1 squared, which is 1, plus this 3 squared, which I'm going to just put as 9. And I'm going to add those together, except I forgot my parentheses. So let me just do this again. If I take negative 3 and square it, that's 9. Plus negative 2 squared, that's negative 2 times negative 2, which is 4. And then plus the 1 squared, plus the 1 squared, plus the 3 squared, which is 9. Now you can see I don't get 0. And so by squaring all of the distances from the mean, I get a number that's not 0. And then, unlike finding the normal mean, where we divide by the number of numbers, because this is a sample, we're going to divide by the number of numbers minus 1. And that's just the way we calculate the sample standard deviation, which means I'm going to take that 24. Oops. I'm going to take that 24 and I'm going to divide it not by 5, but 5 minus 1, I'm going to divide it by 4. And so far, my value is 6. Except to find the standard deviation, we're going to finish this because we squared all the numbers originally. We squared all the distances away from the mean. Now I'm going to take the square root of my 6. And so the 6 is actually called the variance, okay, or the variation between these numbers, but the standard deviation is, if I were to take the square root of 6, my standard deviation is 2.449. That is an average distance from the mean. What that means is that these numbers here have an average distance away from their average, or their mean, of about 2.5. And so that's one way to calculate the standard deviation. What I'm going to have you do is pause the video right now, and I want you to take your calculator and find the standard deviation of these values for the second team. Hopefully you paused the video and were able to do that. What I want to do, though, is show you another way to calculate the standard deviation, and that's using a second formula that is, if you were to Google finding the sample standard deviation, this is probably the formula that you would use, or that you would find. We're going to get the same number that I did before, but it's just calculated in a different way. And so let me clear everything here and show you how this formula works. First of all, what I'm going to be doing here is I'm going to be taking each of these numbers and squaring them and adding them up. So in other words, I'm going to take 72 squared. That's my first number. And then I'm going to add the next number, which is 73 squared. And then 76 squared. And then another 76 squared. And then my final number, which is 78. 78, oops, I forgot to do the plus sign. So plus 78 squared. I'm going to add all those together. So that's 28,149. That's this number here. Well, then what I want to do is I want to subtract the average of all of the squares of these numbers. So now what I'm going to do, instead of squaring all of these numbers and adding them up, what I'm going to do is add all these numbers up individually and then square that and find the average. So in other words, I'm going to take 72 plus 73 plus 76 plus 76 plus 78. I'm going to find the average. I'm going to find their sum, the sum of all of those numbers, which is 375. I'm going to take that and I want to average that. Well, first I'm going to square it. So I'm going to take that number and raise it to the second power. And then I'm going to average that. So I'm going to divide it by the number of numbers, which in this case is 5. So I'm going to divide by 5. And so you can see I get 28,125. Well, according to this formula, what I'm going to do to find the standard deviation is I would take my original number, which is the sum of all the squares. That's 28,149. And then I'm going to subtract the number that I got here, which is the average of all of the square of all these numbers squared, which is the 28,125, which is 24. And then I'm going to take 24 divided by n minus 1. So this might sound familiar because the rest of this is the same as the other formula. I'm going to divide this by 4, which gives me my variance, or 6. And then I'm going to take that number, which is 6, and I'm going to take the square root of that, which gives me 2.449. Same value that I had before, just calculated in a different way. So again, what I'd like for you to do is pause the video right now, and I would like for you to take your calculator and find the sample standard deviation of this team. Go ahead and do that now. Hopefully you've done that. What I want to show you then is to see if we got this number right. I'm going to go to calculate. Note, remember that I still have, these is the first team and this is the second team. If I want to calculate the first team, I'm going to go back to Stat and Calculate and Edit, and the default is List 1. So this S of X is my sample standard deviation. That's what we just calculated, or I just calculated, the 2.449, and we got that using two different formulas. Let's see if you were right. Hopefully, when you did this, I'm going to go to Second Calculate, One Variable Stats, except this time I want to do what I have in List 2. So I'm going to click Enter. The sample standard deviation that you should have come up with the green team is 6.244997998. And so hopefully that's the standard deviation that you got. When you are doing this for the homework assignment, if you want to do it using those formulas, that would be great. However, you don't have to. If you can plug these numbers into your list and then just calculate the sample standard deviation on your calculator, that would be a great way of doing it as well. I'm not going to require you to remember these formulas. I do want you to know how they work and how this number does come about in case you ever have to do it by hand. But because we have calculators, we're going to do it with a calculator. So let's move on. Let's take a look at this next slide. You can see that the standard deviations it says the sets of these two values have different standard deviations. And that's kind of what we just talked about. The average of both of these sets, set 1, which is here, and set 2, which is here. So here's set 1 and here's set 2. You can see that their average for both is 50. So if you were to find the average of this set of data and the average of this set of data, you would get that their average is both 50, but the standard deviation on the second set is a lot higher. So the average distance away from 50 down here is about 40. Like for example, this one's 30 units away. This is about 13 units away. This is about 2 units away. But the average distance, if we add all those distances away, and the way we calculate the average or the standard deviation, it's going to be 14.2 units away from the average, which is 50. Well, in set 1, they're all a lot closer to 50. So there's not as much of a variance. As a matter of fact, the average distance away from the mean is 7.4. So that means these numbers have an average distance away from 50 of about 7.4. Now, what I want you to see in this next slide is this. Here's the data from set 1. we can see that the standard deviation was 7.4.